am at a very special place. I am at the Space Technology Lab of the Physics Department of IIT Bombay, and I have with me Professor Varun Bhalerao. How big is the moment for India today?
It is an extremely exciting time for us, and this is momentous in not just one but two ways. On the one hand, there is the science that Chandrayaan-3 promises to bring. These are explorations of the moon that have not been done by anyone in the history of humanity before. This would be the first mission that can land on the south polar regions, measure seismic activity, magnetic fields, the works. On the other hand, this is also an extremely important technology demonstration. Unfortunate recent event was the loss of Lunar 25 spacecraft by Russia, despite having 15 successful missions before. And that shows you how difficult going to the moon is. And in this context, when we can actually establish a soft landing in the south polar region, that actually proves our technological abilities to the world, but also gives us confidence. All of these technologies would then be shared with industry via InSpace, and that is going to be a big boon for space exploration for all of Indian scientists and Indian population as a whole.
You know, everyone is excited. School children are excited. Scientists are excited. Every Indian feels a sense of pride today. What are your sentiments as a space scientist?
It is a fantastic time to be a space scientist. There are a lot of things that we work on. Unfortunately, people are not quite aware of how advanced Indian space research just is. For example, India has had its own space telescope called AstroSat for about 8 years now, and we regularly use data from that. We have been successful on our first ever moon attempt, first ever Mars attempt. In a few months, we are launching a space telescope that will go and study the sun. So it is a fantastic time for that. And seeing how as a country we are investing into this, investing in our own future, developing technologies that will then percolate through all of our daily lives, it is a fantastic time to be a space scientist.
You know, Chandrayaan-3 is being hailed. At the same time, there are certain questions that I would like to rewind a bit and go back a bit into Chandrayaan-2. When some say that it was a failure, how do you look at it? What is your assessment as a space scientist?
That is a great question. I don't think Chandrayaan-2 was a failure. Chandrayaan-2 was a big, bold attempt. If you, for example, if you are starting from here and you set your goals to just go slightly forward, you are never going to fail. But then you are not really pushing yourself. So as a scientific community, we have to try harder. And ISRO has had this long history of making the impossible things happen. Right? And that's how, for example, the first Chandrayaan mission got everyone's hopes up. And then ISRO really set its sights on extremely challenging goals of doing a soft landing, which is extremely hard to do. The Chandrayaan-2 orbiter was successful. The lander did not succeed. But the orbiter has been giving us immense data. It is the images taken from the Chandrayaan's orbiter's camera, for example, which have allowed us to secure a larger landing zone and be sure that it is actually risk-free for landing the lander of Chandrayaan-3. In similar terms, it is also important to see that because ISRO challenged itself a lot, because it pushed itself ahead, there was a significant risk. I would not have been happy if we were always just playing it safe. And taking that risk meant that there was some chance of failure, but we got to learn a lot. The data that came from the landing attempt has been extremely fruitful in making sure that the newer iteration of this Vikram lander now actually is more capable, that it can withstand the conditions on the moon much better, that it will be able to land, it will not have problems because of dust, because of higher possible impacts, all sorts of things. So it was a necessary step in the continuous ladder of success. It was not a botched attempt.
You know, the kind of progress that India has made in space technology has been tremendous. When you compare it to several other developed nations as well, what is the perspective you have?
The great part here is that Indian space research and Indian space technology is actually developing on par with the countries around the world, and that is something that you cannot say lightly. And that is again a very good factor for India. Indian scientists and ISRO as a whole, and with government support, has consistently worked towards getting better and better space technology. A very important focus in all of this from a national perspective has been that the focus of our space program is that it is fully civilian and it is space for human development. We see results of this at all sorts of places. For example, if you look at cyclones, the predictions that we have are so much better and we can save thousands and thousands of life from that. People, fishermen regularly use data from our satellites in order to decide where to go fishing, and crop prediction, and everything. So the space program, the fact that it has become so advanced, is something that is the result of a lot of hard work by a lot of dedicated individuals, and it is really important that we give them the credit where it is due.
Professor Varun Bhalerao, we are ourselves standing at the Space Technology Lab of IIT Bombay. Please show us around. What is it that you do? Tell us about Daksh. What are the most important projects you are doing right now?
Yes.
Tell us about this.
So let's start with Daksha here. Daksha is actually a proposed space mission, and what we intend to do here is build the world's most sensitive space telescope in high energies. So your normal telescope look at the same light that you and I can see, but Daksha here is going to study the sky in X-rays and gamma rays. And Daksha, the amazing thing about it is that this satellite will be 10 times more sensitive than any other satellites in the world right now, including those built by NASA, by Europe, by Japan, by all these countries which have a greater history for this. And we are building this with the international community hand in hand. The mission was proposed several years ago. We then have built a model, a proof of concept, and we submitted that to ISRO. And ISRO is now evaluating this mission to see whether the full mission should go forward or not. But this actually gives you a perspective of the scale of Indian science again. So IIT Bombay, working together with IUCA, PRL, RRI, TIFR, and various ISRO agencies, we are sitting here and saying we are not just trying to play catch up with the world, we are trying to lead the world. We are trying to build things like Daksha, which will dominate global science for a decade to come. Other than this, there are other aspects of the lab that we work on. So what you see here is data taken yesterday from the Growth India telescope. So this is an optical telescope in Ladakh. And the great thing about this telescope is that it is fully robotic. So when you think of a telescope, you either imagine someone looking through it or maybe someone sitting there with a camera giving commands and taking images. This telescope here is what we do is we tell it a list of what targets we want to observe. And once that is achieved, the telescope takes care of everything else by itself. So for example, in this image, what you are seeing here is a bunch of what you are seeing here is my computer froze. Okay, so what you are seeing in this image is a small part of the sky. The circle that you see here is about half the size of the full moon, but by telescope standards, this is considered a wide field telescope. And one of these little dots that you see here is actually an explosion that happened 1 billion years ago. And its light reached us on the 12th of August for the first time. And we are studying this as it becomes fainter and fainter. And by studying this, we are going to understand how things like black holes are formed in the universe. So this is the country's only robotic telescope so far. And it's by research standards, a rather small telescope. But by daily life standard, it's large. So when you think of a telescope, you think of a lens, which might be of this size or so. This one actually works with a mirror, which is about 70 centimeters across. And it gets us really great results. We also talked about AstroSat a little bit ago. So this here is a little model of AstroSat. AstroSat was built by, again, a consortium of Indian scientists from across various institutes. I was fortunate enough to be a part of the team that built this, and this was launched in about 8 years ago now. And with AstroSat also, what we've been doing is studying a large variety of sources. Scientists all around the country, scientists abroad. AstroSat is a very well-respected instrument around the world. My group here and the students who work with us, they all work primarily on search of these cosmic explosions, what we call gamma ray bursts. And AstroSat is one of the best instruments, again, all around the world to see these explosions. So these are sometimes even called mini Big Bangs because they are so energetic. In a fraction of a second, this exploding star emits more energy than the sun will emit in 10 billion years. And we have seen about 600 of those explosions with AstroSat so far, and that has all given us great scientific returns.
So exciting times really for Indian space technology, not just with Chandrayaan-3, which is a huge leap, but as you can see here at IIT Bombay, which is involved in great research in space technology, this Daksh as well, which is coming on the way.